So hello everyone, whosoever have joined right now. Good morning, good evening to you. Can you all go on mute? Or if you have any question or anything to say, you can put in the chat. We will open the session for questions when I will finish, right? So we are here to understand what we are going to learn under SQL Server query performance tuning and optimization. So this is the 11th batch that I'm starting from 14th, perhaps. I have written 13th or 14th. It's from Wednesday, from 14th, right? So we will have the demonstration class today and tomorrow. I have scheduled it for 2 days demo classes because I think that I will check more than an hour to complete the syllabus, to explain it, what are the topics we are going to cover under this syllabus. So then for technical discussion, today we will have less time. Tomorrow we will have complete technical discussion on performance tuning on few topics, right? So tomorrow also the demo class will be at the same time, right? Now, before I start SQL Server query performance tuning and optimization, right? So you all have joined this session. It means that you are eager to know about it. You are curious to know about it. And anyway, you understand its importance. What is the importance of query performance tuning and optimization as a SQL DB and developer? You understand its importance. So before I start, let me tell you how the industry trend is changing right now, or I would say has completely changed. Whosoever are working as SQL DBA, earlier they were not responsible for performance tuning, right? But nowadays, companies are looking for those DBAs who are well versed with query performance tuning, who have good knowledge in PowerShell scripting, who have also knowledge in different flavors of SQL Server, especially in Azure SQL, right, has again the different flavors, single database and managed instance. So these are the things nowadays are expected from most of the companies by most of the companies from DBH. And if you are a developer, then you must have, of course, good knowledge of query performance tuning. But as a DBA, you must have a good knowledge of SQL Server level 10 tuning and query level tuning. So that is the agenda of this course. We are not going to cover all the aspects which is right now in demand in the market. Those courses are delivered by me under different courses. For example, there is a batch that is going on for SQL Server DBH from beginning to advanced level. And yeah, people are learning some advanced things, and those who are beginners, they're also learning there. Earlier, I finished one batch for PowerShell for SQL DBH. Before that, yes, and one batch is already going on SQL Server performance tuning and optimization that will, complete very soon. So that is morning batch. Okay, so let me introduce myself a little bit here. I'm Neeraj Mishra. I have more than 20 years of experience in IT industry. I started my career as a teacher, and I taught in different institutions for more than 4 years. After that, I joined in one of the company as assistant writer. There I wrote some computer books. So I worked there for only 3 months. And after that, I started my own freelance working for writing computer books. So I have written more than 30 computer books, starting from 6th standard to BTech or MCA standard. Just before 14 years, I joined in a company as a SQL Server database administrator. And right now I'm working as a SQL technical architect and SQL performance engineer. Basically, these are the two major roles that I'm performing right now. So far, this online training is concerned, I have been delivering this training since last 2 years, but before that, I was delivering classroom training. So in India, almost in most of the companies, I have delivered trainings on SQL Server administration, SQL Server query performance tuning, T-SQL development, and PowerShell for SQL DBAs. 4 courses I have delivered. Although I have delivered many trainings, but few are to highlight here. One of the training I delivered in UA University for DBH. That was a 6 to 8 days training. Another 2 trainings I delivered for scientists for National Informatics Center India, government India, that is owned by Government of India. And there were 54 participants, all were scientists from grade B to grade D. B, C, D, right? And that training was conducted on behalf of Microsoft, and I was the trainer on behalf of Microsoft there. So this is all about me, and let me start to talk about the syllabus, that what we are going to cover. So this is the title I have given to the course, SQL Server Query Performance Tuning and Optimization. It is usually based on SQL Server 2017. So far, SQL Server query performance, SQL Server performance tuning and optimization is concerned. Yes, from server prospect, there is a little bit difference between older version and SQL Server 2016 or 17. But from query prospect, if you talk about query performance tuning, although the concept is same. So let us have a look what we are going to cover in this course first. So let me put this in slide mode. So when we talk about performance tuning and optimization for any database, any relational database management system, such as SQL Server, Oracle, DB2, MySQL, right? So there are 3 prospects of performance tuning and optimization. The first is SQL Server configuration and database level settings. That is on server level and database level, right? The second is query level tuning, that is on query level tuning and optimization. And the third aspect is database design. So the first one that you see there, tuning on server level and database level settings, comes completely in the basket of or the responsibility of DBH. The query level tuning comes most of the time in the under the responsibility of developers or DBAs, but as a DBA, you have to assist them, right? And if you want to become a good performance engineer, you have to learn query level tuning as well, right? So when I'm working as a SQL performance engineer, I have no space to say, right, that I cannot tune queries, right? I have to do that. But yes, of course, while you are working as a SQL performance engineer, you don't have understanding inside the data. So you will have some problem in understanding the business logic, right? Why the where condition is put on a particular column, right? How the condition has been tightened. There are different things that you will not understand, but you can discuss with the developers or the people who have good knowledge of the data which is related to a particular business, right? And after that, you can guide them that how you can tune the queries. The third is database design. And it is very hard to enter into this area or this aspect of performance tuning because this database design is done by your database architect, or they are also known as database designer. And once the database design comes into play, once it is deployed into production, it is very hard to make any change in the database design, right? Although you will see that there are some flaws, there are some loop and holes in the database design. If you highlight them, those flaws, right, that needs to be go through many approvals, and there is a chain for approvals. It take a lot of time, and most of the times it is not allowed until and unless there is no way to go ahead, right? You will see that it will be not allowed. So we will have a little bit discussion on database design. Majorly, we will focus on query level tuning, server level tuning, and database level tuning. So these are the three aspects that we are going to cover during the course. And whatever you will learn in this course, that will, roam around these three these three aspects of performance tuning, right? Whenever we talk about performance tuning, right, we must know about the killers which exist in SQL Server, right? Uh, just talk about an analogy. If anyone is suffering from a disease, right, first he has to diagnose. And during the diagnosis, a doctor can diagnose through the test or from his or her own experience that from which kind of virus or viral or bacterial infection that person is suffering from. Once he is diagnosed, then doctor prescribes the medicines, right? So when you have to work on performance tuning, when you have to tune SQL Server or queries for improvement of their performance, you have to diagnose the killers, that which killer exists or what are the different killer exist which is causing which is killing the performance of either of SQL Server or the performance of queries, right? So these are the major killers that exist in SQL Server that you will learn during the course. One of the most important killer is here, you can see on the list, is poor indexing, or sometimes it is, there are two different terms, poor indexing and missing indexes, right? Poor indexing is different than missing indexes. We will talk on that. Another is stale statistics or outdated statistics. We will talk on that. It plays a very important role in performance tuning. If your statistics is outdated, your query, the estimation of number of rows on which a particular operator has to operate will be wrong. And when the estimation of number of rows to be reached on which a particular operator has to operate will be estimated wrongly, certainly the performance will be killed. So we will talk on statistics very deeply, I will tell you. Poor query design is a very major concern, right? Where developers write their code and they don't understand the meaning of making a relevance of indexes and the columns which they are using, say, for example, for joining two tables, or where they are specifying the predicate or the condition with the where clause on which on which column the index is not created, right? So there are multiple things. If they are doing some kind of explicit conversion in the left-hand side of the predicate, or if there is any implicit conversion happening due to mismatching of data type on which the predicate is based on, right? There are a lot of things that we have to consider under poor query design, right? So even though you are a good developer, but you don't understand that what are the different things that make a query design bad or make a query design poor, you cannot write an optimized query. You can write a good query, but you cannot write an optimized query, right? So the fourth point that you see here is a great problem with the store procedures that I have experienced, right? That is known as bad parameter sniffing, right? So for that, you can see there are three terms: bad, parameter sniffing. Bad can be replaced with good also, right? So you will have to understand what is a parameter, what is the meaning of sniffing, how parameter sniffing happens, and when a parameter sniffing becomes bad. When a when a parameter sniffing becomes bad, that's why it is called as bad parameter sniffing, and it happens basically with the stored procedures which are used with input parameter values, or stored or simply parameterized queries, right? So although parameterized queries are good, stored procedures are good, but they may suffer with this problem, bad parameter sniffing. So we will have to understand about this. Blocking and deadlocking, these two are the natural phenomena in any RDBMS, in any relational database management system. And this blocking and deadlocking do not only happen in any relational database management system, but they happen in any multi-user system. So blocking and deadlocking are the scenarios which can happen, are the phenomena which can happen in any operating system as well, which is a multi-user operating system. For example, it can happen in Windows Server editions, right? So blocking and deadlocking, these two are the natural phenomena that are supposed to happen in any RDBMS, but excessive is bad. So we will have a detailed discussion on blocking and deadlocking. But before that, you will have to understand the transaction concurrency control mechanism in SQL Server, where there are two mechanisms implemented in SQL Server. You can either implement, one is known as pessimistic concurrency control mechanism, and another is optimistic concurrency control mechanism. So the four isolation levels that you have: read uncommitted, read committed, repeatable read, and serializable. They fall under pessimistic approach of concurrency control for transactions. And the one isolation level, that is a snapshot, which has two variants in SQL Server: a snapshot and read committed snapshot. So that follow optimistic concurrency control approach, right? You will have to understand isolation levels, and before isolation level, you will have to understand what are the different anomalies that may exist with transactions, right? So your anomalies are such as dirty reads problem. One is phantom read problem, right? There are different kinds of anomalies that you have. Uh, and how isolation level helps you to eliminate those anomalies, right? That we will discuss. Then you will have to understand the different kinds of logs which are used under SQL Server, which are used by SQL Server transactions. Uh, Basically, shared logs, update logs, and exclusive log are there. Apart from that, you will have to understand the concept of latches. Then you will have to understand the concept of log granularity, log escalation, right? Then you will have to understand the concept of blocking, then deadlocking, then how to capture blocking using extended event or profiler, how to capture deadlocks using extended events or profiler, how to capture deadlock graph, how to analyze that, and how to resolve such problems. So this is a big topic, right? Another killer that you see is a cursor in SQL Server. This is a killer. Cursor is the only, uh, you know, uh, object available in SQL Server which supports non-set-based operations. Whatever operations you perform, right? Whether you perform any join operation, inner join or outer join, right? Or you perform any union operation, right? Intersect, if you perform intersect, whatever you are performing, or even you are executing your select statement to, without any joins to get a set of rows which is based on your condition. In that case, whatever data you have stored in a table or in different tables is known as a data set. So SQL Server, all operations apart from cursors are performed against a data set, and they return a data set against the result of your queries, right? So all are set-based operation apart from cursors, and cursor follows a concept of concept. That term is known as rebar. It means that uh, it reads rows which are stored in a table or in a view one by one. So it's very similar to your audio object that we were using in Visual Basic, right? So cursor is not a good option for operating on data set or operating on a table which has more than 50,000 rows. But still, as a DBA, you can use cursors with your system views or the tables which are part of your sys schema, right? For administrative purposes, you can use. So wherever you have less than 50,000 or 40,000 rows, I mean that if you have a small table, you can operate with cursors. Performance will be not much degraded there. But cursor is obviously a killer against large data set, against large tables. Poor database design, it's a big field, but this in this we will not explore a lot. We will see a few things that what comes under poor database design. There we will have some emphasis on data integrity, how you can implement integrity of data by implementing domain integrity, entity integrity, and referential integrity. There are three kinds of integrities which we implement in database design to ensure data consistency, right? So domain integrity is implemented using check constraint in SQL Server while you are designing the table. Then entity integrity is implemented using primary key and unique key in SQL Server during the database design or table design. And referential integrity is implemented with a combination of primary key and foreign key. So uh, these data integrity, three integrities, not only ensure the consistency of data, rather they also helps optimizer in improving the performance of queries. But if you have not implemented these integrities properly in your database, or if your indexes are poorly designed, right? If your queries are not being satisfied with the index that you have created, that database design is not good, right? So this is a big topic. We will talk about two things there. One is data integrity, and another is index design. Fragmentation is natural in any storage space, I would say, wherever you write data. So fragmentation also happens on operating system level, right? But we will talk more fragmentation that happens on index level. So fragmentation is natural as the rows are being inserted, deleted, and updated. Those index pages will be fragmented there. But excessive fragmentation is not good. When I say excessive, so any fragmentation more than 30% is not good, right? We have to understand how to find the fragmentation level. I think most of you know. If you don't know, I will explore these all things. Will teach you during the course, right? Using the DB index physical stat, one of the DMV, we find the fragmentation level of each of the index in the database, and accordingly we plan to reorganize or rebuild the indexes. So there are some conditions, we will talk about that. Non-reusable execution plans are a major concern of query performance, right? So whenever you execute a query, and suppose that every time that query has to be compiled, so whenever that query will be compiled, a new plan will be generated. And it does not only happen with you. There are hundreds and thousands of users connected to SQL Server. So if for most of the users, right, queries are being recompiled over and again for the regeneration of the execution plan of those queries, they will consume a lot of CPU. So in that case, your CPU goes high. Your CPU utilization is always high in that case. So you have to overcome this, right? By using different techniques that we will talk about. The preferred method is to not allow ad hoc queries to be, executed on the server, right? Ad hoc queries are those queries which plans are generated every time you execute the query. Those are known as ad hoc queries, right? I was interviewing one candidate and I asked the question that you have 18 years of experience. Tell me what was your achievement during this tenure? So he answered that he did some performance tuning. I asked them that what you did in performance tuning. So he replied that he did performance tuning for what I was talking. Uh, what I was talking. Mm. Yeah, ad hoc queries. He did performance tuning for ad hoc queries. My first question was, what do you mean by ad hoc queries? He didn't answer that. A person who does not understand the meaning of ad hoc queries, how he can, troubleshoot, how you can tune those queries, how he can convert those ad hoc queries into, parameterized queries, or how he can convert those queries into stored procedures with input parameters. So basically, those queries which are parameterized queries are those queries which are a stored procedure with input parameter values, or those queries which are executed using sp underscore execute SQL statement, right, are considered as non-ad hoc queries, and their execution plans are reusable. Means that if the same query is executed by any other user, either from application or directly, its plan will be not, most of the times its plan will be not, regenerated. Okay. So Santosh, let me complete the syllabus first, right? Then I will answer your question, parameter sniffing, okay? So the important thing to understand here, why I put it as a killer, because generation of execution plan is a very, costly thing, because it consumes CPU, many CPU cycles or CPU time, right? So why to generate the execution plan of a query for each of its execution, right? Why not we execute a query once, and the plan, whatever has been generated, should be used over and again, right? Then the same thing happens. This non-reusable execution plan is pretty much related with this concept, the killer, frequent recompilation of queries. You cannot stop recompilation of queries completely, right? But it should not be frequent. So what does it mean? That whenever you execute a query, and if it is compiled over and again, that is recompilation. Recompilation is done for the generation of execution plan, right? So whenever you execute a query and its plan is generated over and again, we share that we share that query is being recompiled over and again, right? So there are many factors which lead to the compilation of queries. For example, if statistics are updated at that time, if recompilation of the queries are being performed, we are fine. That is natural, because statistics are not updated on frequent basis, right? Whenever you introduce a new indexes in your table, at that time queries are recompiled. Whenever you make any changes in the table design, you either add a column or you remove a column, or if you add any constraint in your table, such as check constraint, primary key, or foreign key, if you are altering your table, your queries related to those tables will be recompiled. Those are natural, but it should not happen frequently. That is the objective, right? When the recompilation of queries happen frequently, it's a killer. And this happens due to two factors majorly. The first factor is your ad hoc queries. If most of the queries are coming as ad hoc queries, then yes, of course, you will see frequent recompilation of queries. There are counters in perform. There are counters to find the number of recompilations per second in performance monitor. You can do that. We will talk about that during the course. The second reason behind recompilation of query is, yes, of course, your memory pressure, right? So if SQL Server is feeling memory pressure, right, it's not only the SQL buffer area where the pages are, flushed by lazy writer to the data file or to the disk. Rather, plans are also flushed from the plan cache. Those who have already been reached its aging factor, or those who have already reached their age. And even though those plants which have not reached their age, in lazy writer, flushes those plants as well from the plant cache, plant cache, right? So that is the problem. And when the recompilation of queries happens frequently, it becomes a killer. Improper use of cursors, as I already told, that as a DBA, you can use cursors against your system views or system tables, which exist under CSS schema for automating anything related to DBA stuff. But you should not use cursors against large tables, which have usually more than 50,000 or 40,000 records. Then in proper configuration of database log file, what does it mean? That you should not host your data file and log file on the same disk drive. The reason behind is that data in data file is read and written randomly, and data in your transaction log file is read and written sequentially. That is the main reason. These two have different read and write nature, right? So if the same spindle of the disk has to perform these two tasks, one in the random fashion and another in the sequential fashion, right? That makes your access of data pages from the data file and reading or writing transactions in the transaction log file somewhat slower. So you must host your data file and logs files, transaction log file, on separate disk drives. Excessive use or improper configuration of TempDB, right? There are two terms I have used under the performance killer. So let's talk about excessive use of TempDB, right? As a developer, you should not excessively use your TempDB. You should take care of, so what happens actually, if you have to operate on a small set of data that can fit in the memory, right? You should not use TempDB. Whenever you are operating with large set of data, you can go and use TempDB, because TempDB is on the disk. Reading and writing data on the disk is 20 to 22 times slower than reading and writing data in RAM, in physical memory. RAM is known as physical memory. So you should not excessively use TempDB. Improper configuration of TempDB is what? That, sorry. It depends upon the number of processors that you have assigned to SQL Server. Accordingly, you should assign your data file in the TempDB. For example, if you have 4 processors, you should assign 4 data file. You should create 4 data file in TempDB with 1 log file. And all the data files should have same initial size with same auto growth. That is the fact that you have to keep in mind from the performance point of view. So this is all about the killers. Apart from that, there are few killers also. Those comes under these subsections. When we will talk those things, that they will come into picture. As a DBA, you have to make sure that your SQL Server and database is properly configured to ensure that performance is optimum from the server and database point of view, right? So for that, you have some important settings there, right? One of them is affinity mask. So far, I understand that it is less understood by most of the DBH. I will highlight it. I will keep, I will tell you many a story around this, what I did for affinity masking, how you can do, and in what situation I implemented this, or you should implement this. Memory configuration, this is related to your setting minimum memory and maximum memory for SQL Server, right? What should be your minimum memory? What should be your maximum memory? That is the topic we will talk about. These two settings, max degree of parallelism and cost threshold parallelism, plays a very important role in optimizing parallelism in SQL Server for the execution of queries, right? What should be its value? For that, Microsoft has defined, some standards. We should follow that. And if you go ahead and ad hoc workload. Yes, I talked about ad hoc workloads, ad hoc queries. So ad hoc workloads are the term that is related to your ad hoc queries. Am I audible to all?
Yeah,
Hello?
yeah, yeah.
Am I audible to all?
Yeah,
Okay. There was a big silence. I thought that.
because we are on mute.
Yeah, it's good. You should keep yourself on mute. Otherwise, any background noise is coming that will disturb the recording, right? So after the training, I will share this recording with all of you. So if the quality will be good, that will be better for you. Meanwhile, uh, meanwhile, I'm talking about this. Can you all go ahead and put your email IDs in the chat box so that I can send you this class recording, today and tomorrow also, after the class with all of you, because I don't know from which source you all have come. Maybe you might have come from the different Facebook groups. Someone might have come from LinkedIn. I don't know. So many of you, I might not have your email ID. That's why I'm requesting. So put your email IDs in the chat box. I will send this recording to all of you along with the syllabus once again. Okay. So there is a setting on the server level. If you cannot if you are not able to convert all your ad hoc queries into parameterized queries or in stored procedures with input parameters, there is one option that is known as optimized for ad hoc workload. There is one configuration setting on server level. Let me show you here. But I will have to come out from here. Let us come to SQL Server, how I can come out. Why it is locked? Where is the minimize option? Do we have any minimize? Yes. So let me come to, where is my management studio? Why it is showing so? Here it is. So here, uh, you all should know, I believe so. sp configure. If you see more than 72, 75 rows here, it means that your all parameters or your all server level configuration options are enabled. It means that so advanced options is enabled on server level. Here you have the list. I have enabled them. I am talking about this option. Show advanced options. Where is that? Show advanced option. If its configured value is 1, you will see 73 to 77 rows in this list. If it is not enabled, if it is disabled, you will see only 20 to 23 rows. So you can see the affinity mask that I talked about has 4 configuration options available on server level. Affinity mask for CPUs and affinity IO mask for this again applies to CPUs for IO operations. Then it has another variant, affinity 64, which is applicable when you have more than 63 CPUs on the server. So we will talk about that, how to affinize your CPU with SQL Server instance. We will talk about that. Likewise, you might have seen that you have many. What is happening? So likewise, this cost threshold of parallelism, max degree of parallelism, mean memory, max memory, these all are your server level settings or server level parameters that you can set to optimize the performance of SQL Server. Likewise, you have optimized for ad hoc workloads. So if you are unable to optimize or convert your am I audible to you?
Yeah.
Yeah. Yes, now.
Sorry.
Yeah, a few minutes back you were not get audible.
The network was lost. Wi-Fi was not available, so that's why now it is available now. So I have 2-3 networks ready here. So don't worry, it will not take more than half minute to come back if any connection is lost. Sound is good.
Yeah,
Yeah,
yes.
it's good now.
Okay. So what I was talking about fill factor. This is also well misunderstood, right? And by default, it is left to 0, which should never be, right? What I'm talking, those who are not from DBS background, they can understand it. If you go to server instance property by right click on the instance name properties, and if you go to database settings, you have the default index fill factor. So fill factor can be set on server level. Fill factor can be set on a spatial index level as well, right? If you specify fill factor while you are creating an index, right, that will override the server level fill factor value. So here it is 0. 0 means 100%. What does it mean? That index page will not split to the next pages until unless that index will be filled with 100% data. So while I'm saying that, it seems good, right? That if my pages are being utilized 100%, I'm utilizing my storage space in very efficient manner. But more the index fill factor, especially if you have 100% fill factor or 90% fill factor, you will see more fragmentation. We will talk about that why. So the optimized fill factor that I suppose should be 70 to 80%, right? And I will demonstrate you through a live example where I will create where I will create some tables, some indexes. I will create some tables and I will create some indexes there, but with different fill factor. We'll have same data, but you will see how the indexes are fragmented with 100%. There you will see 100% fill factor. The fragmentation level is very high. And with index fill factor 70 or 80, index fill factor is pretty much controlled, right? I have demonstrated that to almost every batch. So you should not go with 100% fill factor, right? That improves your index fragmentation. That is in a nutshell here, but we will talk more about that during the course. Blocked process threshold is what, if you want to capture, your blocked processes, the sessions which are involved in your, or the transactions which are involved in your blocking scenario, if you want to capture those using extended events, right? So you have to define a time that what should be the threshold. If a blocking exists for more than 10 seconds, then you want to capture in the extended event, or if blocking lasts for just more than 5 seconds, then you want to capture it all. It's all on you. So this is the server level factor, server level parameter that you have to define for capturing block process information using extended events or profiler. Database file layout, as I discussed about that, that your data file and log file should not be hosted on same disk drive. Reason behind is that they have different read and write nature. Database compression is a good thing, but it saves one hand, it saves your space, so it saves your cost of a storage. But another hand, wherever your database pages are compressed, before reading the data, those have to be uncompressed. So it's a CPU intensive operation. So it's all about storage versus CPU cost, and obviously CPU cost, CPU is more costlier, and more importantly, CPU time is more important for us, for our queries, for the performance. So nowadays, we do not opt database compression. We do not use it at all. But yes, of course, we go with backup compression. Whenever we check backup, we should go with the backup compression, so that again, it will take less space on storage. And while we are transferring that backup file over the network from one server to another, it will take less bandwidth in the network. Keep your statistics up to date. This is very important for the performance. Even you have written a very good query, the query is fully optimized, you have right indexes, but if your statistics is stale, it is out of date, your performance of query will be completely degraded. So why statistics is so important? For that, we will have to understand what statistics is, what data is stored in statistics, and how query optimizer uses statistics in order to estimate the number of rows to be read to perform a particular operation, right? Those are the things you will have to understand that. So we will have a complete session on this. Then you have to maintain a minimum amount of index fragmentation. For that, you must schedule a index maintenance job with some logic that if there are less than 1,000 pages in an index and index fragmentation level is even more than 20% or 30%, go for reorganize only. But if there are more than 2000 pages in an index and my index fragmentation is more than 30%, we should go with rebuild of indexes. You should cycle your SQL error log file periodically so that whenever you are reading something from the error log file using the XP read error log or SP read error log command, right, that will take less time. You should not enable two options on your database, auto close and auto shrink, right? There is a big drawback of these two. We will talk about that. You have to consider about the database backup, about its schedule, right? Especially for full backup and differential backup, you have to think about its schedule. You should not schedule full backup and differential backup during your business peak hours, and you should not take backup of the databases on the disk drive where your data file, log file, or temp DB is hosted. It should be on a different disk drive. While you are taking the backup, you should go with backup, encrypted backup with compression. These are the things from security point of view. You should go with encrypted backup, and from a storage point of view, you should go with compressed backup, right? So these are the things you will have to consider here. You have to consider about the transaction log backup frequency also, or the differential log backup frequency also, how you are taking that. That also, plays some role in server level performance tuning. Backup distribution, I already talked about that. This backup should be taken on a different disk drive than the drive where your data file, log file, or temp DB is hosted, right? And apart from that, if you are taking a backup of large database, which you have to transfer to another server, especially for migration purpose, so go for a striped backup in that case. So apart from that, there are a few things also we will talk about on server level and database level. Likewise, on database level, one very important factor is auto growth. That is not listed here so far, I remember. So auto growth plays a very important role in performance tuning of SQL Server also, right? We will talk about that. Then we are entering into query design part. So earlier I told you that even though you are a good developer, but if you don't know about the performance tuning techniques, right? You cannot write an optimized query. You can write a good query. You cannot write an optimized query, right? So let me check the chat. Perhaps we have lost most of the email IDs. Yes, I lost. Guys, please ping once again because I lost the connection. That's why you see here that we lost the email IDs. So ping your email IDs once again so that I can send you the recording after the class. Well, while you are writing your query, it should be a parameterized query, or it should be your query should be part of a stored procedure. Anyway, its first statement should be set no count on. The reason behind is that if set no count on is not written as the first statement in your stored procedure or in your parameterized query, then what happens? Whatever SQL Server performs, whether it performs any update or insert or delete, or even it performs select read operation, right? It returns information that this many number of rows affected, right, to the client. So don't think that you are only one user and SQL Server is returning this to you. Like you, there are hundreds and thousands of users connected to SQL Server. And for each and every user, if SQL Server is returning certain messages, right, to the client. So when you connect to SQL Server, you usually connect using Management Studio. You can connect using SQL CMD. You can connect using any application. You can connect using PowerShell script, right? So these all are treated as client. And your SQL Server is a server. So SQL Server acts as a client server model. And client sends the request to SQL Server processes that, and it sends back the result to the client, right? So during the course, while it is sending back result to the client, it also sends one message that this many number of rows affected. So that is an additional message being passed over the network for hundreds and thousands of users. It unnecessarily consumes the network bandwidth. So it's a good practice to start your queries or a stored procedure with set no counter on a statement. Second rule of thumb for query optimization is you should explicitly define the owner of an object. So while you are specifying a table name in your query, say for example, you are writing a select query where you are joining two tables, and even though, so it may be a chance that those two tables are coming from two different schemas in the table, right? So you should explicitly define those schema, or even they are coming from the same schema, you should explicitly define the schema, right? Otherwise, what will happen? SQL Server will start to search that object from the DBO schema. So that is unnecessary, taking your time. So that is not a good practice. This might be a new term for many of you. Avoid non-searchable search conditions. So for that, you have to understand what a condition is, what a search condition is. Search condition is also known as predicate. And when a search condition or a predicate becomes searchable, and why you should not use any non-searchable search condition. So I cannot explain it right now, but the rule of thumb is that non-searchable search condition always lead to table scan or index scan, and searchable search conditions always leads to index seek. Seek is always faster than index scan or table scan. That is why you must avoid writing non-searchable conditions in your queries. Avoid arithmetic operations on where clause column. So while you are writing any query, right, and when you want to limit the number of records, let me show you here, or let us discuss as it is. So you usually put a where clause, where condition, right? And in where condition, there are two parts, right? One is left part and another is right part. So where, say for example, where I'm writing a query, select star from sales order, sales order detail, where sales order ID equals to 4359, right? So after where I have written a condition, sales order ID equals to 4359. So from the equals to sign, the left hand side, we have a column sales order ID, and right hand side, we have a value. You should not write any expression in the left hand side, of your condition. Likewise, you should not write sales order ID multiplied by 10, something like that, or you should not apply any substring, right, that left sales order ID, comma 3 equals to this value, something like that. You should not apply until and unless it is not hard and fast to apply any, to write any expression or any function in the left-hand side of the column. You should avoid that. You should avoid optimizer hints. Many of the people use hints while they are writing queries, right? So for example, many of the people use no lock hint, update hint, join hints, index hints, right? Many of the people use such hints. So optimizer is very smart, and it knows that how a query can be executed well using different operators, right? So don't specify any, hint to your query until and unless it is not hard and fast. And then after applying that, you must have a proof that the query performance has been improved after implementing that hint in the query. Then only you should go with the optimizer hint. Otherwise, most of the time, you should avoid that. You should stay away from the nesting views, We will talk about what is a nesting view and why you should not use nesting views most of the times. There should be no implicit data conversion happen in your query. So this is a very hidden thing that happens inside the SQL Server, and you can understand it only if you have good understanding on the plan, execution plan. What happens? You have written a very good query, but if any kind of implicit data conversion is happening in your query, right, its performance will be degraded, because implicit queries again always convert your seek operation into index scan. That's the drawback. You should minimize your logging overhead. How you can minimize your logging overhead, that we will talk. I will show you through some examples that while I am inserting, say, for example, 10,000 of rows, how much my transaction log has grown when I am inserting those 10,000 rows under a loop without a transaction, So every insert is treated as a transaction in that case. But if I treat uh, the entire insertion of 10,000 rows as a single transaction, if I am keeping those all transactions under a single transaction, right, in that case, you will see that the transaction log size is not growing. It means that we have minimized the, not growing too much, we have minimized the logging overhead. So this is a very good technique to improve the performance while you are writing the transactions. We will see this during the course. Adopt best practices for reusing execution plan. What are the best practices? It starts, the first practice is you should encourage the use of store procedures and store procedures with input parameters. If that is not possible, you should use parameterized queries, right? And if any dynamic SQL statement you are executing from the application, you should execute using sp__ execute SQL store procedure. So those are the best practices, so that the plan of the queries will be not, generated over and again. And we are using the same execution plan for executing the query. Adopt best practices for database transactions, right? That we talked about here. Is eliminate or reduce the overhead of database cursors that we already have talked. And apart from that, there are other things too that we will go in deeper during the course for the query designing. While we are talking about database design, so the major area of focus is about the integrity design, data integrity design, that is implementing domain entity and referential integrities in database design. So how we can benefit from that? Apart from the data consistency, we also gain performance from the optimizer and ultimately from the SQL Server. So I will show you through examples. Perhaps Kripa Anand has joined. Kripa, are you there? I saw you have joined recently.
Yes, sir, I'm there.
Okay. So tomorrow morning we will have class, and perhaps I'm going to talk about these topics, right? He is my student from regular batch. I just saw that you have entered here.
Yes,
Okay.
sir.
Then here is, your tables should not be over normalized, should not be under normalized, right? And usually, this is not your responsibility, right? But if you observe that that there is a problem with table normalization, you can highlight it to the database designer. They can think over that, right? But it is very hard and fast to make changes in the table design. Then yes, of course, we will talk about index design best practices, right? What are the different kinds of columns which are best suited for creating cluster index? In which case you should create non-clustered index, in which case you should create column store index, in which case you should create covering indexes, in which case you should create composite indexes. These all are the things we will talk about. You should not create any stored procedures starting with sp underscore, because your system stored procedures are starting with sp underscore, which are defined within your sys schema. So if you name any stored procedure with sp underscore, certainly if you execute that, first of all, that will be searched in sys schema, and unnecessary, it is taking time, right? So you should not name your any stored procedure starting or suffix prefixed with sp underscore. And finally, you should minimize the use of triggers, because especially server level triggers, right? Because they are cpu intensive, but if it is necessary, you have to use them. This is very important part of performance tuning and optimization, right? Here you have to understand the execution plan, and in the working with the execution plan, right? So in the execution plan, you have to understand these all concepts. So there are different component of your optimizer. The first component of your optimizer is a parser, followed by your algebraizer, and a subcomponent of algebraizer is binder or name resolver. Nowadays, it is implemented in the IntelliSense of Management Studio itself. But when IntelliSense was not implemented in Management Studio, at that time, binder comes in picture only when you execute the query. So first component is parser, another is algebraizer. Perhaps it is not in picture here. Then the third component is your query optimizer. Fourth is query executor, right? So there are four components which comes in picture when you execute your query. It starts from the parser. Parser parses your query against the syntax. If there is any syntax error, it is reported to you. When you debug those errors and again execute it, the query is passed well passed. The resultant of parser is a parse tree. Then that is passed to algebraizer. Algebraizer does the name resolution, and also then it creates an algebraizer tree, and that algebraizer tree is passed to query optimizer, and query optimizer may create one plan or multiple plans depending upon the number of indexes which matches of the predicate part of the query. So guys, many of the terms that I am using, you may not be able to get. That is what the agenda of the course. Everything will be simplified during the course. You can get those things very easily, right? And ultimately, your query optimizer may create one plan or multiple plans, and finally, it select the least cost plan, because query optimizer is a cost-based optimizer. It's not a rule-based optimizer, it's cost-based optimizer, right? So the least cost a plan has, that is selected by your query optimizer and handed over to query executor for the execution. So these all are the things that you will have to understand. This comes under the complete flow of the execution of the query, but you will have to understand. So this comes under execution of the query plan, right? Execution plan generation, right? Whatever I discussed, this comes under that. Then once you understand that, you will have to understand what are the different components of execution plan. So execution plan consists of, let me show you here. Let me come out from here. I can see only 8 people have pinged their email IDs right now. So I would encourage you all to ping your email IDs, right? So that I can send this recording to all of you at the end of the session. Not today, tomorrow will be more technical session there. Today I'm trying to explain the syllabus here, right? So you will get the video recording. What is happening? Okay. Let me put these email IDs here. Okay. where I was. Here. Here. I was here, right? No. Here I was. Is it visible to all?
Yeah.
Yeah.
Oh, okay. Okay. It's better. I have to switch from here to there most of the times. So what
Yeah.
I'm talking, let me show you here. Mm, if I can show you something that would be better. So simply just change this to this query, select it from here. Just let me show you the query execution plan for this query. I think double S is wrong here. So for that, what you have to do, okay, this will not work because connection is lost. So let us open a new query window here. Let us change the database context and let us execute this. But before that, let me capture the execution plan. I can capture the execution plan in two modes. I can capture estimated execution plan without executing the query, or I can capture actual execution plan after executing the query, right? So let us capture this plan after executing the query. Query and include actual execution plan. You have to select, after that execute the query. So come to the execution plan. And you see, this is my execution plan. This execution plan is the graphical representation of the binary code of this T-SQL statement or T-SQL query. Let me reiterate it. This graphical execution plan that you see here is the graphical representation of the binary or object code of this T-SQL query or a statement, right? Here, you see many icons. Every icon is a physical operator in the execution plan. Optimizer supports more than 200 physical operators. We will learn about near about 20 to 30 important operators. While you are being interviewed, you are asked a question that what are the different operators that you usually don't want to see in the plan and why? So the answer is, I don't want to see any scan operator in the picture, whether it is table scan. If it is table scan, it is more, it is worst. If it is index scan, it is also not good. I don't want to see any lookup operator in the plan. If it is against a table, then it will be simply, lookup. If it is against a clustered index, then it will be, it will be RID lookup. If it happens against a table, if it happens against a cluster index, it will be key lookup. So I don't want to see RID lookup or key lookup. I don't want to see short operator, right? I don't want to see, in the most of the cases, I don't want to see, one of the join that is known as hash join, right? I don't want to see any kind of a spool operator. Operators, a spool are, there are different kinds of a spool operator. One is lazy spool, another is eager spool. Again, in eager or lazy spool can be against a table or can be against an index. So you may have index eager spool or index, what is the another term I used? Lazy spool, or table eager spool or table lazy spool. So I know that many of the terms I am using right now, you may not be aware, right? But this should be my answer if any interviewer is asking me the question that what are the different operators that you usually don't want to see in the plan, right? Apart from that, I also don't want to see any kind of implicit conversion warning, right? So if you do not understand what I am telling right now, nothing to worry. That is the objective of this course. We will talk about these all things with many examples. You will have very clear concept on those. But obviously, you are going to be asked these questions nowadays in interview. Definitely, this is the first question that interviewer asks in performance tuning. What are the different operators that usually you do not like to see in the plan and why? So that is what I was talking about, execution plan. Let us come back and talk about these things. So we'll talk about aging of so components of the execution plan you saw there. And here only few operators are there. Let me close this, come here. Only few operators are there. So these are the components here. You can see index seek is one of the physical operator. If you hover over the mouse, you see the tooltip here. This tooltip has 4 sections actually. The first one gives you many information about the estimated number of rows to be read and actual number of rows that has been read. What is the physical operation and logical operation that has been performed, right? That is important. And most important is their estimated subtree cost that we will talk about when we will talk about cost threshold for parallelism value, setting the cost threshold for parallelism value. At that time, you will see that how I am calculating this estimated subtree cost and from where it is coming. Then in the second section, you see that on against what object this operation, seek operation has been performed. So it should be a clustered or non-clustered index, but here it is written clustered index. So it has been performed against the clustered index. The name of clustered index is pk underscore cells order detail. You can see under object section, cells order ID, cells order detail ID. Then what are the different column it is returning that comes under output list, and what is the condition that you have put is coming under your seek predicate. These are the things you will learn. So each and every operator has some tooltip and it has its own meaning, right? And you can see that data flows in the execution plan from right to left. First, the index seek is a physical operator. It is an access method provided by the storage engine to the optimizer to access or read data from the disk, because your indexes are also stored on the disk, right? So first, index seek performed some operation. It has read, how many rows? 12 rows from the cluster index. And after that, it passes next to the computer scalar. Then it passes it to next computer scalar. And finally, that has been passed to select operation. So here you can see that here is a arrow also, right? That indicates the flow. If you hover over the mouse over the arrow, you see that how many rows it is returning to the parent operator, right? So this is the child, this is the parent, this is the parent of this one, and finally this is the parent. So every operator is passing some rows to the next row. 12 rows it is passing, and finally you have 12 rows here, right? This is just an overview that how we what we have in the execution plan, but more will come in picture when we will discuss these all things during the course. Next, you have to optimize for an ad hoc workload, and there is the setting that you have under this. Okay, if we don't have, we can write. Let us come here and simply execute this sp underscore configure. So here we go. And you will see one of the option is there, optimize for ad hoc workload under O. MNO. Optimize for ad hoc workload. The configured value is right now 0. I can configure it with 1. sp configure followed by this. I can put it here, right, comma, and 1. Within single quote, comma, 1. If I execute this, my ad hoc workloads or ad hoc queries will be optimized for the performance. How it is optimized, we will talk about that. Right, and after that, whenever you make any change on server level, you have to override that change by executing the reconfigure statement. Right, it is a good practice to override the default setting with reconfigure by executing reconfigure statement. Now, forced parameterization is a bad thing, I would say, right? You should not go with that. What I'm talking about, that even if you are executing a ad hoc query, which is a non-parameterized query, perhaps you will not get that, most of you, if you are not a developer. Developers can understand. Then even though you don't have a parameterized query, you can force every query to be executed as a parameterized query by uh, enabling it on the database level. So you should go to the database properties, and by default, the parameterization is set to simple. Another option is there forced. If you set parameterization to forced, where is that? Do you see here? Parameterization, you can see it is set to simple. You can, if you set it to force, even though you execute a query as a simple query, sorry, ad hoc query, which is not your parameterized query, but still optimizer will treat that query and generates the plan as a parameterized query. It's not a good practice because it may give birth to bad parameter sniffing, right? So we will talk about that. What are the next thing we have? What are the benefits of a stored procedure? We will talk about that. A stored procedure is a once compiled object. Whenever you execute that, right, it compiled once, and for the subsequent execution of the stored procedure, whatever queries you have written within that stored procedure, they are not compiled over and again, because it's a once compiled object. That is the first benefit. What is the second benefit of a stored procedure? Uh, your complete business logic is written on a centralized place in the database. So whatever changes you have to make, you can make changes on the centralized place at once, and that is applicable for your application. If any module is calling that, you don't have to. If that business logic is implemented in application code, right, you will have to make changes over and again on different places in your application code. But if it is implemented in a stored procedure, it's at a centralized place, so you have to make changes at only one place. That is the second advantage. Third advantage is that you can control access to for the execution of that stored procedure to a number of users. You can allow or disallow users to modify those stored procedures, right? So there are many benefits of that. XP execute SQL statement is usually used to execute dynamic SQL statements, right? We will talk about that. And this also makes your query, in the category of non-ad hoc queries. So it's a good practice to execute your dynamic SQL statements using a SP execute SQL. Parameter sniffing, we will understand what is parameter sniffing and when it becomes bad. And when it becomes bad, the simple sign of bad parameter sniffing is that your stored procedure execute in different times. Sometimes it will execute in 5 seconds. Sometimes it may take 50 seconds or 5 minutes. Sometimes it will take 30 minutes. In different times it will execute. That is the first sign of bad parameter sniffing that happens with stored procedures or your parameterized query. We will talk about that. Query plan has and query has, we will try to understand that, because this understanding can help us in identifying the duplicate plans in plan cache. So sometimes your plan cache is completely filled with duplicate plans, and in that case memory pressure is is generated in SQL Server, and that memory pressure ultimately leads to high CPU utilization as well. So many of the times you will have to identify duplicates plan, right? I have complete document on that. So you will be provided with, so whatever topics I am talking, I have complete document on that, right? So you will be not provided only with the class recordings, each of the class recording, but also you will be provided with documents, right? Then what are the recommendations for maintaining execution plan cache that we will talk? These two statements, set statistics time on or off and set statistics time IO or on or off, plays a very important role in performance tuning and optimization of your queries, right? These two gives you the facility to capture that how much time a query took to execute, right? That is captured using set statistics time statement. So when you say to execute your query, that involves your uh, pass time, compile time, and code execution time. These three things you can capture using the set statistics time. And there we mainly focus on code execution time. So while you are tuning the query, if you can reduce the code execution time of your query, you can say that, yes, you have tuned the query, right? Likewise, set statistics IO on facilitates you to capture the number of scans, number of logical reads, number of physical reads. Those happened in order to perform a particular operation against different tables. Those are part of your queries. So say, for example, uh, let me show you here. If I simply execute this statement uh, in a different window, say, for example, uh, with this statement set, let us first capture logical reads and physical reads. Statistics IO on, and this is my query, right? Let it separate as execute as two batches, execute it, and come to the message here now. So what you see that it has captured the IO statistics for this query execution. What are those IO statistics? One is scan count happens, right? And then 3 logical reads happened, right? We are basically interested in physical reads and logical reads, and 0 physical reads. So physical read happens when pages are read from the disk, when they are not available in SQL buffer. Logical reads happens when the pages are available in SQL buffer, right? So a scan count is 1. Here a scan count may happen against the index or table scan. You will see only a scan count here. So this information is captured here, right? Now, if I also capture the time, right? So this will give me the picture that how much time my query took to execute, how much time my query took to pass, compile, and execute. Let us execute that. Come to the message now. You see here, parse and compile time is 5 ms, right? And then your code execution time here captured here. How much time your query took to execute? It is 0 ms. So whenever it takes less than 20 ms, that is shown as 0 ms. It doesn't mean that your query was executed in 0 ms. Maybe it has taken 2 ms, 5 ms, 10 ms, like that. It may have taken, right? So these two plays very important role. Now let me come back and also capture the execution plan of the query. So let us capture the execution plan by include actual plan. Come to the execution plan here. So this is going with cluster index seek, right? And if I come to the message under IO, so it is going with index scan count 1. Okay, it is reading all the rows first, and after that it is reading the required rows with 3. So that's fine. So during the course, you will see if I will write some problematic query that is taking a lot of time, how to tune those. So objective is here to reduce the what time. You cannot reduce the parse and compile time, right? But you can reduce the code execution time that is captured under here, right? So these two statements plays very important role. Next is your estimated plan versus actual execution plan. So let me show you here. It's estimated plan first. You will see some differences. Where is my estimated plan? So estimated plan under query, display estimated execution plan, right? So if I come here, you will see in the first section, estimated number of rows to be read. Estimated number of rows is 12. Right, you do not see message like actual number of rows that has been read, right? That you do not see here, right? But if I capture the actual execution plan, it will give me more information. Let us execute it. Oh, it was not captured. Now you see in the first section from the top fourth or fifth line, you can see number of rows read 12 and actual number of rows 12, right? And here you see estimated rows, number of rows to be read. In the first section from the bottom, it should be 1, 2, 3, 4, 5, 6 line and 7th line, 12, 12. Estimated number of rows to be read 12 and estimated number of rows is 12. If you do not see difference between these two, the estimated number of rows to be read and the actual number of rows or number of rows, actual number of rows that those has been read, right? Then it's a good sign. Your statistics is not outdated. If you see slight differences between estimated number of rows to read and actual number of rows, nothing to worry, right? It means that sometimes what happens, estimated number of rows to read comes in decimal form, where the reason behind is that statistics do not have the matching adject matching entry in its histogram. What I'm talking, I will explain tomorrow. It will take a lot of time to explain that. That's why I'm not entering in that area. Okay. Okay, Jace. So what I was talking, let us come back. Here. So that is the reason you have to understand the difference between actual plan and execution plan. The main reason behind that is you should not see much difference between the estimated number of rows to be read and actual number of rows that has been read. If you see much differences between these two, it's a sign of outdated statistics, and certainly that will decrease the performance of your query. That is why it is important to understand. We'll talk more on that. Then next, let us go somewhat faster. Okay, which slide I am? Here, after that, indexes plays a very important role in query optimization, right? So we will start from the very basic. What is an index? Basically, we have what is an index? We will talk. Then we will talk about index analysis. We will talk about index design, best practices or recommendations. We will talk about row stored index and column stored index. These two have again these two categories, clustered and non-clustered. We will talk about their internal structure along with how we can create, and we will talk about advanced indexing techniques also. And under that, we will talk about covering index. That should come next to eliminate the lookup operator. So when you are talking about indexes, statistics are directly related to your indexes and columns also. But first we will talk about statistics which are based on indexes. right? And during the course, you will learn about index fragmentation analysis, causes of fragmentation, fragmentation overhead, how you can analyze fragmentation, amount of fragmentation in your indexes, right? What to do when you have fragmentation in a small table, nothing to worry. If you have fragmentation more than 30% in large table, then you have to rebuild your indexes. And even in a small table, you have 50 or 60% of fragmentation, nothing to worry. What are the fragmentation resolutions? So resolution is setting the fill factor properly, then maintaining your index fragmentation, either using rebuild or reorganize indexes with the scheduled job. And yeah, that is directly here, significance of fill factor, and then how you can automatically maintain them using jobs, database maintenance jobs. This is the second one. What is an statistics? What is a statistics, and how we can perform a statistics analysis? What is the role of a statistics in query optimization? Maybe I will discuss this tomorrow, right? That will be very interesting session. So you must attend that. Because statistics is, well, not very well understood by most of the DBAs and developers, and it plays a very important role in your performance optimization. So we will talk about that. Statistics on non-index columns. So basically, you have two kinds of statistics in SQL Server. One is based on your indexes, and another is based on your columns. So we will talk about we will talk about the statistics, maintenance also, right? And we will analyze the effectiveness of statistics for a query by example. Next, while I was while I put one question that what are the different operators you would not like to see in the plan, one of the operator I named was lookup. There are two kinds of lookups. When SQL Server looks for data in a table, right, that refers to your RID lookup, and when it looks up data for data against an index, it is known as clustered index. It is known as key lookup. So lookups are not good, and obviously I don't want to see any lookup operator in my plan. What are the drawbacks of lookups? I will explain with very good examples, and how you can how you can analyze that what causes the lookup, right? And how you can resolve lookups using the covering index, how you can create covering index, and then you can eliminate that from the plan. So the treatment of any kind of lookup is covering index. There are three kinds of joins. Am I in the right slide? Yes. There are three kinds of joins that optimizer uses for joining two tables. So whatever joins you perform, whether it is inner join or outer join, right? That is performed by SQL Server using three join operators. One is hash join, another is merge join, and the third is nested join. No join operator is bad. It depends upon the data set, how you are joining, and the nature of data set, and the columns on which you are joining the tables, whether they have indexes or not. So you will have to understand this properly. These play a very important role in performance tuning and optimization. If you have good understanding on these three joins, right, you can do a very good performance tuning wherever you are joining many tables. Next, query compilation is natural, as I told you, but excessive of everything is bad. And here, if excessive recompilation is happening in SQL Server, that is bad. So there are benefits of recompilation of queries as well, but if it is excessive, there is a big drawback of that. Then what statements are Okay, what I was talking. I was talking about that if excessive recompilation is happening, then how you can capture those statements which are causing recompilation, right? That we will talk. And then obviously, apart from those statements, there are other causes of recompilation also, as I talked earlier, that updation of statistics, introduction of new indexes in the table, introduction of any new constraint in the table, such as check constraint or primary key constraint or foreign key constraint or unique key constraint. Then I also talked about if you add any new column in the table. All right, so there are many causes of recompilation. We will discuss them as well. And sometimes in order to increase the performance of your queries, you have to explicitly recompile the query, or you will see the use of explicit recompile in case of bad parameter sniffing. I will show you through some examples right during the course that when to use recompile command explicitly. You should avoid uh, how you can avoid the compilation caused by statistics changes, right? That we will talk about because that is very important. Let us go next. In SQL Server 2014, from performance point of view, in-memory optimized table was introduced where the data is always stored in memory itself. Obviously, you will need more memory to store the data in tables which reside in memory only. But many people think that data resides only in memory. Yes, of course, the read and write operations happens in memory, but at the same time, in order to recover the database in case of any crash happens of database engine, right, there must be some mechanism of database recovery. So for that, it maintains some files in terms of SDR file. It maintains there, right? That is somewhat in nature of a streaming kind of file, streaming media kind of file. It maintains behind the scenes and from where it does the recovery. But of course, data resides in memory and all read and write operations are performed in memory optimized table. But the story is not ending there. You can gain maximum performance or the optimum performance from memory optimized table only when you execute your query as natively compiled stored procedures, right? So to gain the maximum benefit from in-memory optimized table, you have to execute your queries within a natively compiled stored procedure. There is a difference between SQL Server regular procedures and natively compiled stored procedures. Natively compiled procedures are, compiled using Visual C++ compiler. And again, if you are creating a memory optimized table, you must create some hash indexes on the columns, right? Hash indexes. So the best performance of memory optimized table is achieved when you execute your query using natively compiled stored procedure, plus you are using hash indexes. We will have hands-on session on this. Then this is a very large area. Perhaps I discussed about that, right? The same thing is there. This is for transaction concurrency control in SQL Server. And you can see there are different things that comes under in locks, locking, lock operations and mode, log granularity, isolation levels, blocking, capturing blocking using extended events and profiler. What are the blocking resolutions you have? Then automation to detect and collect blocking information using extended events. In part 2, you will see deadlock is there, right? So what deadlock is, how you can do deadlock analysis, what are deadlock fundamentals, how deadlock occurs. Under that, we will read how you can capture deadlock using profiler and extended events. Those who are from programming background or working as performance engineer, they should have some idea of catch and try block, how you can write your complete transaction within a catch and try block, so that if any deadlock happens, if my transaction is a victim of deadlock, I can resubmit that transaction for the execution, right? Those are the things here. Then these are the different tools that we will talk during the course for performance tuning and optimization. Of course, I have been naming these tools: SQL Profiler, Extended Events, but you see new tools are here. Query Plan I treat as a tool. The query plan that you see here, I treat as a tool, right? So query plan comes in different forms. You can see query plan in text form, in XML form, and in graphical form. Most of the times, we prefer to see execution plan in graphical form, not in text and XML form, right? Then next tool that you have is Plan Guide. It is very useful, right? Whenever you want to execute a particular query with a particular execution plan, you can use the Plan Guide. Live Query is a tool that is introduced in SQL Server 2016, but it is more CPU intensive. So it gives you the picture of your query, how it is executing. It gives you the live picture of your query, right? And Query Store is one of the a very good tool introduced in SQL Server for performance tuning, right, of your queries. Whether it is a database level feature, you have to enable it, but it works as a tool. And this has been implemented in Azure SQL, right, as intelligent, what is that? Query Insights. Query Intelligent Insight is implemented using Query Store there, right? So it gives you the picture of your regressed queries, the most CPU intensive queries. These are the different kinds of information you can get through Query Store. And even you can force a plan to execute with a particular Query Store as well. We will have a discussion on that. Then the most misunderstood thing, but yet very important, troubleshooting CPU memory, troubleshooting high CPU memory and IO utilization, right? This is the day-to-day task that most of the DVAs face, right? So we will have detailed discussion on that. And there we will start our discussion with SQL Server Architecture. And I will talk about SQL OS first, then I will talk about scheduler. I will talk about scheduling mechanism, where we have two mechanisms, cooperative and preemptive scheduling mechanism. SQL Server follows cooperative scheduling mechanism, right? And then we will talk about scheduling algorithm, cooperative and preemptive. We will talk about thread life cycle. We will try to relate these things with max degree and cost threshold for parallelism. And here comes the role of, weights, your weights and statistics. So related to the CPU, you have three wonderful weights. One is your scheduler yield, another is thread pool, that is not here in the picture. Another is CX packet, right? These are the three wonderful weights that you have for capturing, analyzing CPU utilization by your server. So these are the things I would try to explore tomorrow, or see whenever time will allow. I will try to explore these all things. So tomorrow I will start my discussion with performance killer. After discussing two or three killers, maybe I would jump into this field. This is very advanced thing, right? And you have to understand these all things if you want to be a good troubleshooter. So I think that we are done. Next, maybe with troubleshooting memory utilization, troubleshooting IO performance, and troubleshooting TempDB performance. So during the course, we will talk about more IO weights, more weights which are related to IO. That is which comes under page IO, latch, in update mode, page IO latch in exclusive mode, page IO latch in shared mode, right? These are the weights that you will see when you have high CPU utilization. So I will try to give you the picture of performance killers yesterday, and if the time will allow, I will also enter into SQL OS, which is one of the major component in SQL Server. There we will talk about SQL Server settling mechanism using cooperative settling algorithm. It's a very advanced topic, so don't miss that. Those who have dropped, I don't know whether they will be aware about this thing, but I will send recording to all of you. You will be so they will also become aware about that. Meanwhile, let me put some informative message for you now. So we are starting the batch from 14th, right? And tomorrow we will have again the demo session at the same time, 9 p.m. to 11 p.m. So don't miss tomorrow's session, right? And we will start the batch from 14th, and timing will be decided whether it will be the whether it will be the night batch or will be the morning batch, based on the entry of participation and the votes. I have both slots free now. The morning batch, I will be free from 14th or 15th, or from 16th. So it will be a regular batch. Daily we have the classes of 130 hours, starting from 9 to 9:30. It would be either 9 a.m. to 10:30 or would be 9 p.m. to 10:30, right? The course fee is 10K in INR, and those who are from outside of India, they will have to pay $160, right? So that is the course fee, and those who are interested, they can drop me a mail. I will reply them, right? Or I am putting my number here in the chat. I am also available on WhatsApp. You can ping me on that number. So the country code is 91 plus 91 hyphen 875056123006. This is my number. You can, okay, I have to ping you all, everyone in the meeting, right? So you can call me on this number if you have any questions regarding the course, regarding the fee, right, regarding the schedule. If you have any question, you can call me on this number. But once again, I will reiterate my statement that don't, miss tomorrow's session. That will be very advanced one. So I can see who else are here. Dorian. Hello, can you hear me, Dorian? Max, it would be too late for you, right?
Oh, it's okay.
Okay. Okay. Anybody apart from Max outside of India?
Yeah, Rafiq is from Pakistan.
Oh, good to know, Rafiq.
Thank you.
That's good. Oh, anyone else? Dorian, can you hear me? No. So it's fine. If you have any questions, any queries, feel free to ask. Otherwise, I am fine to wrap up the session for today. And the same meeting invite that I have sent to all of you, you can use that to join tomorrow meeting. So see you tomorrow then. If you don't have any question, I am fine to wrap up the session.
Thank you.
Thank you very much then.
Thank
See
you
you
very
tomorrow.
much, Raj. This was a nice session, informative session. Thank you very much.
Thank you.
Thank you, Niraj. Thank you. Bye.
Thank you. Bye.
Thank you, Raj.
Bye-bye.
Yeah, thank you. Bye.
Thank you. Bye-bye.